Okay, I found a question, but before we go into it, I'm just going to point out some things about light as a particle and as a wave. And you may already see it, but the difference between particle and wave is light comes in packets, waves are continuous. That's one of them. And we'll show how this plays out in the photoelectric experiment. So in the photoelectric experiment, if we have a packet coming in, either the packet has enough energy, HF, for the electron to come out. Show you by a big packet. So let's call that HF. And that's a piece of light. If there's enough energy, an electron will come out. If it doesn't have enough energy, the electron's just going to stay still. The key point in here is it's immediate. It's an immediate yes or immediate no. Okay. For continuous, basically this is like having a wave. Okay, so it may take some time. It's drawing out. It will take some time for the wave to build up, and then the electron will come out. So if we have high intensity waves, that means more waves coming in, then the electron will go out really quickly. But if the wave takes if it's really low intensity, then it'll take a long time for the electron to get the energy to come out. Okay, so this one takes time. So that's our first point. So if we look up here, right, this is question 2 of 2006 or something, but it's still relevant. This is the question that it'll relate to. Light of low intensity will give rise to the emission of photoelectrons later than light of high intensity. So if we have one electron and only a tiny piece of electron coming, not much intensity, so like one ray of light coming in, it'll take a long time. Whereas if we have lots of rays of light coming in, then it'll come out really quite quickly. So this would be a yes. Okay, and there's another thing I want to add to this in a second, but yeah, for now that's good. But whereas if you look at the particle model, if it's high intensity, what does it mean? That just means we have more particles coming in. And remember, either this particle will be like immediate yes or immediate no. Either way, it's immediate, so it won't take any more time. So that should be a no, which it is. The other thing about particles and waves is that particles don't interfere, and waves do. So what does this mean? A particle energy comes in a packet, and each of these are separate. Okay, each of these is HF, and then the number of these is the intensity. So it's a high intensity. Low intensity would just be like one ray of light. Whereas waves, they can all interfere with each other. So the energy is not separate. Like you could combine these two waves to have more energy. So the energy for a particle model is only dependent on frequency. It's the energy for each of these. Whereas interference can occur here, so energy is dependent on frequency and intensity. Because if we have more waves, we can combine them to make one super huge wave. That's kind of the idea. So how does this play out? Well, we can look here. Light of high intensity will produce photoelectrons with a greater maximum kinetic energy than light of low intensity. In the wave model, that's true, because now if the electron receives this huge piece of energy, it's going to go move really fast. But in the particle model, that's not true, because this electron can only receive light from one of these packets. Either it takes it or doesn't. And then if it takes it and it goes, it's based on that. More intensity just means more electrons are coming out. So this one would be no. It's not true for the particle model. Light of sufficient intensity of any frequency should produce a photoelectric event. Again, this is to do with the same idea. Remember, we have a threshold frequency. I don't know where to write that. Basically, if this electron isn't getting enough energy from one particle of light, then it's not going to come out. And that's what we found. So even if we ramp up the intensity, it doesn't do anything, because it's only based on the frequency. The energy is only based on the frequency. So this has to be a no. Because if we have a low enough frequency, we don't get enough energy, we can't get the electron out. Whereas for light, we can add them all up together again and then get the light out, get the electron out. So this would be a yes. I hope that kind of clears it up. So if you want me to summarize all that, I'd go for particles and waves. Particles are immediate, waves take time. Now the energy of a particle only depends on HF, or our energy formula, whereas for waves it depends on frequency and intensity. So it takes time. High intensity means more energy. High intensity means any intensity, increasing intensity can make up for smaller frequency, which particles can't. That's the summary. Okay, cool. I'll be moving on to matter next.